Hello everyone, this is Hetty. In this video, let's learn chapter 5.3, trig functions of any angle. In previous lesson, we have learned the 6 trig functions for the acute angle. So we have acute angle, that the acute angle, that means the angle less than 90 degrees. So it's in the first quadrant, it's in this area. So if I have an acute angle, I can find the 6 trig functions. In this lesson, if an angle is here, here, or here, maybe it's negative, maybe it's positive. So we're gonna learn the trig functions for any angle. We orient the triangle with the angle theta. For example, this graph, this right triangle, with the angle theta in the standard position. So put this in the xy plane and label the point P as xy on the terminal side of theta. So this point is on the terminal side of theta. So in this triangle, so this length, this side, the value is y because the point here is x, y. So here is y. So you just move this part to here. The length is the length of the opposite side of theta is y. How about adjacent side? The value of adjacent side, that's x because it's located on the x-axis. Right now, you're clear about the length of opposite and adjacent. Why I claim that? Because we use this information to find the 6 trig functions. Since we know the x and y, we know if we have a right triangle, we have y and x here, we can easily to find the hypotenuse because the hypotenuse equals x squared plus y squared. R equals square root of x squared plus y squared. So by this way, we find the R. So in this right triangle, we can find the sine theta equals opposite divided by hypotenuse, which is y over r. Cosine theta equals x over r. Tangent theta equals y over x. That's the opposite divided by adjacent. And find the cofunction of these three. So sine theta's reciprocal is cosecant theta equals r over y. Secant theta equals r over x. Cotangent theta equals x over y. So in this way, we can find the 6 functions. So for any other angles, when we find an angle here in the second quadrant, third quadrant, or fourth quadrant, we still can use y over r, r over y. We also can still use all of this. So let's see the table. Trig functions for any angle. Let's theta be an angle in standard position with the point P xy on the terminal side. Let r equal square root of x squared plus y squared. It's not equal to 0. Represent the distance from P x xy to 0, 0. So sine theta equals y over r. Because we already proved that. So you just memorize this table. Wherever the point or the terminal side is located, we can always use this formula to find six trig functions. Actually, you only need to memorize 3 and then do the reciprocals to find these 3. Okay, let's move on to second part. Determine the sign of the trig functions. Why we are looking for the why we use these 2 tables to show you, because we know the point in the first quadrant. This is 1, 2, 3, 4. There are 4 quadrants. In the first quadrant, the points are always be positive. So x value is positive, y's value is positive. And in the second quadrant, x is negative, y is positive, because this is x value and this is 0. So this side is positive, this side is negative. So the x value is negative. Y's value I can find from here as positive. In the third quadrant, negative, negative. Fourth quadrant, positive and negative. So we have learned that sine theta equals y over r. Cosine theta equals x over r. Tangent theta equals y over x. So in the first quadrant, y is positive and r is the length, so it's always positive. It's the length between here, the P point, to the origin. From here to here, it's always be positive. This is positive in the first quadrant. And this cosine theta x in the first quadrant is positive. So it's greater than 0, greater than 0. Y over x, they are both positive, so it's greater than 0. This is the first quadrant. How about the second quadrant? Second quadrant, the P point for second quadrant is negative, positive. So the sine theta equals y over r. R is always positive. Y here is positive, is greater than 0. How about cosine? X over r is negative because here is negative. So tangent theta equals y over x is negative because x is negative, y is positive. So the division is negative. So you don't need to memorize the other 3 trig functions, because cosecant theta equals 1 over sine theta. If sine theta is greater than 0, the cosecant is greater than 0. If secant theta equals 1 over cosine theta, if cosine theta is greater than 0, they're both greater than 0. Cotangent theta equals 1 over tangent theta. If tangent is greater than 0, it's greater than 0. So they have the same, the co-functions have the same sign. Here is a trick to help you memorize where when the theta located, what's the sign for each trig functions. Here is the xy plane, the 4 quadrants here. 1, 2, 3, 4. So all students take calculus ASTC. That's all students take calculus. So all means all, that means all 6 functions are all positive. And student S here means only the sign is positive. T means only the tangent is positive. C means sine is, cosine. C means cosine is positive. If cosine positive, so the cofunction secant is positive. If t is positive, cotangent is positive. If s sine is positive, cosecant is also positive. Okay, let's move on to see evaluating trig functions. Let the point to be -2, -5. I'd like to draw the graph first. -2, -5. So let's find the point. It's here. The point on the terminal side of the angle theta drawn in standard position. Find the value of the six trigonometric functions of theta. The distance between the origin to this point, which is -2, -5. That's the R. R equals the distance between these 2 points. I can use the formula of the distance between 2 points. That's -2, subtract 0, because this is 0, 0. Use x minus x value minus x value squared plus y minus y. That means -5 minus 0 squared. Let's see, what's that? That's 4 plus 25. That's square root of 29. Right now we know the R, and we also know the x and y. So we know x equals -2, y equals -5, y R equals square root of 29. So we know that sine theta equals y divided by R. So just plug in all the information we have had here. That's -5 over square root of 29. Sorry. The cosecant equals the reciprocal of sine. That's R over y. That's negative square root of 29 over over 5. Sorry. Because I just do the reciprocal of this. Cosine theta equals x over r. Plug in the x, which is -2. R is square root of 29. Secant theta equals r over x. That's negative square root of 29 over 2. Tangent theta equals y over x. That's positive because -2 over -5, that's 2 over 5. Cotangent theta equals 5 over 2. So we find all of these 6 functions. Okay, let's continue evaluating trig functions of quadrantal angles. Find the value of sine, cosine, and tangent for the given angle. Right now, they gave us this. Okay, they gave us an angle, this. So I'd like to draw it on the I'd like to draw it on the XY plane. So 3 pi over 2, I know this is pi, this is half pi, this is 3 pi over 2. So the point, the terminal side is here. If it is here, we can just assign any point on the on this negative part of y-axis. I can choose, it could be 0, -2, or 0, -1, 0, -3. It doesn't matter. Just choose any point on the negative part of the y-axis. So right now we have the x and the y's value. R's value equals square root of 0 minus 0, because 0 and 0 zeros, this between these point distance is 0 minus 0 squared plus -2, subtract 0 squared, that is 2. So R is positive 2. X equals 0, y equals -2, R equals 2. So we can find the 6 trig functions. They only ask the sine, cosine, and tangent. So sine theta equals y over r, that's -2 over 2, that's -1. Cosine theta equals x over r, that's 0 over 2, that's 0. Tangent theta equals y over x, that's -2 over 0. So you see the 0 appeared in the denominator, so this one is undefined, because you can't have something like this or anything like this, a number on the top and bottom is 0. So this one is undefined. How about cotangent? Cotangent theta equals the reciprocal for tangent. That means 0 over -2. The bottom is not 0, and the answer is 0. So this one is defined. Only the tangent theta is not is undefined. Okay, let's move on to see next one. Theta equals 180 degrees. So find it from the graph. This is 0, 90 degrees, 180 degrees. So the point is here. I can choose any point on this part. The example choose -1, 0. So if we choose -1, 0, the r's value is here. From this point to this point, the distance is what? Is -1 subtract the 0 squared plus 0 subtract the 0 squared, that's 1. You can also use x squared plus y squared, because 0 here is nothing, just like you subtract nothing. That's the x squared plus y squared. Okay, right now we have the x equals -1, y equals 0, and r equals 1. Plug it in the trig function formula. Sine theta equals y over r, that's 0 over 1, that's 0. Cosine theta equals x over r, that's -1 over 1, that's -1. Tangent theta equals y over x, that's 0 over -1, that's 0. How about cotangent theta? That's a reciprocal of tangent, that's -1 over 0. So 0 is in the bottom. This one is undefined. Okay, let's continue to part 2. Determine the reference angle. What's that reference angle? Let theta be an angle in standard position. The reference angle for theta is acute angle, and theta prime formed by the terminal side of theta and horizontal axis. That means if I have an angle, maybe this is theta, and the terminal side is here. The reference angle is formed by this terminal side and the x-axis, that is here, because it's acute angle is less than 90 degrees. So between this one and this one, I must choose this angle because this is the acute. How about I have another, if I have another angle, the terminal side is here. So the terminal side and x-axis, the angle formed by this and this, the acute angle must be here. How about I have angle terminal side at here. So if the original angle is theta like this, and the terminal angle of theta is this, because between the terminal side and axis, and also the angle must be the acute. So the angle is here. Some student ask me, if I have a negative angle like this, so my angle is like this is theta. What is the reference angle? You don't need to worry too much things, because reference angle is just depends on where the terminal side it is. So the terminal side is here, the x-axis is here, so that reference angle is here, the acute angle. And how about in the first quadrant? The first quadrant, the reference angle is between this one and this one, so it's just like this. So let's see these four pictures. The first one, if in the first quadrant, the terminal side is here, x-axis is here, so the theta equals its reference angle. In the second picture, in the second quadrant, the terminal side is here, the angle between the terminal side and the x-axis. Remember, that's acute angle. So the theta prime is here. The relationship between theta and theta prime is use 180. All of this, subtract this part. So I get theta prime. Or in the radian form, you use pi minus theta. Next picture, if in the third quadrant, 1, 2, 3, 4. In the third quadrant, the theta equals all of this theta, subtract 180. So all of this, subtract this part, that's the theta prime. In radian form equals pi equals theta minus pi. Next picture, in the fourth quadrant, that equals 360. The full rotation, subtract this part, we got this. So the full rotation is 360 degree minus theta. In radian form, that's 2 pi minus theta. Okay, let's move on. Find the reference angle. Theta equals 315 degree. So you should actually, for me, I'd like to draw the picture, draw the point first. So in degree form, so this is 180, is 90 degree, is 270. And here is 0, 360. If one full rotation, that's 360. So, okay, so 315, that should be here. because it's greater than 270, less than 360 is here. The reference angle must be here. That equals 360 minus theta. 360 minus 315 degree. Made mistake here. 315 degree equals 45. So the reference angle is acute positive angle equals 45 degrees. Next one, theta equals negative 13 pi over 12. This one, I'd like to convert it to the positive angle because I can use a coterminal angle, coterminal knowledge to find the coterminal angle. So I know if this angle plus 2 pi, it still keep at the same terminal side. So I use negative 13 pi over 12. That equals negative 13 pi over 12 plus 24 pi over 12. That's 11 pi over 12. Okay, for the positive angle, it's easier to draw. So this is pi over 2, this is 3 pi over 2. So this angle is between here and here. So it's here because pi equals 12 pi over 12. So it's less than pi. So the angle between is in the second quadrant. The angle between the terminal side and the x-axis must be here. And what is that? I can use pi subtract 11 pi over 12 because this one from here to here is 11 pi over 12. So the reference angle is pi subtract 11 pi divided by 2. This one is 1 over 12 pi. This is a reference angle. Let's continue to see second one. Theta equals 3.5. So we have learned that in degree form, this is 0, 90, 180, 270 degrees. But in the radian form, I know this is pi over 2, pi, 3 pi over 2. This is 0. And when we rotate it to one full rotation is 2 pi here. How about 3.5? Because pi over 2, that's 3.14 over 2. That's about 1.57. I can use 1.57 represent pi over 2. And this one is 3.14. And this one, I can use 4.71. So it's between here. Between this one and this one is in the third quadrant. In the third quadrant, the reference angle is here. That equals, so theta prime equals 3.5 subtract pi. Next one is theta equals 25 pi over 4. This one, I can draw the picture, but I know that I'd like to find the coterminal angle to make it simple. So because 25 pi over 4, that's a very big angle. I know that I can use theta plus or minus n times 2 pi. Okay, decide what is n, because I know I must subtract because it's so big to make a smaller coterminal angle. So 25 pi over 4 subtract let's see, I try 3. No, that's 2. Yeah, that's one works because 2 pi can convert it to 8 pi over 4 because I'd like to have same denominator. So it equals 25 pi over 4 minus 24 pi over 4. That's pi over 4. So this one is very simple angle. So it's here. The reference angle equals pi over 4. Next one, okay, is 100. That's very big. So I'd like to see which angle. I want to find the coterminal angle and make it very close to an angle. So it's in the fourth quadrant. It's here. So what should we do? Since we know that in the fourth quadrant, I can use 2 pi subtract the coterminal of theta. So right now, I can also say I can use n times 2 pi because the theta now is too big, and I don't want to find the coterminal, but because it takes me too much time, I can use this formula, which is n times 2 pi subtract theta. And then at the end of the result, I must to have a smaller angle and positive smaller angle. So I'd like to try which n I should choose. So the theta, I have 100 and the pi is 3.14. Just assume 3.14. 2 pi equals 6.28. Subtract 100. And then I have find that 16. When n is 16 times 6.28 is a little bit more than 100. Let's see, 16 times 6 times 20, 628, 16 times 6. So 16 times 6.28, what is that? A little bit more than 100. So that's what I'm looking for. This one is difficult. So this one equals 100.48 subtract 100, 0.48. So the reference angle is 0.48. You won't have this kind of difficult question in your homework, but this one is very interesting one. You can think about it and just for fun. Okay, next one, evaluate trigonometric functions using reference angle. Actually, the absolute value of a trig function, for example, absolute value of sine theta, that equals the absolute value of sine theta prime. This is a reference angle. This is the actual angle theta. So the only difference between the trig function and their reference angle trig functions, the only difference is the sign. Maybe this is positive, maybe it's negative, but their absolute value always be the same, including cosine, tangent, cotangent, secant, cosecant. So that's the way we can find the absolute value of the trig function, and then we can decide the sign of the trig functions, just to say that's a positive or negative. So this is the way how we find the trig functions by using the reference angles. To find the value of trig functions of a given angle theta, determine the function value of the reference angle. That means we find what is sine theta prime, because you know theta is always acute angle. So acute angle means the sine theta prime is always greater than 0, always positive, because in A, S, T, C, in this quadrant, acute angle, the six trig functions, they are all positive. So this one is positive. So when we know this, we can use this value to decide the actual value of the sine theta. Next one, fix the appropriate sign, the positive or negative, based on the quadrant in which theta lies. That's the meaning of A, S, T, C. All students take calculus. So if it's here, all the sine value is positive. If it's here, all the tangent value is positive. If it's here, all the cosine value is positive. Okay, let's see. This one we have learned before. So you just memorize these special angles trig functions. And next picture, we have learned this. So for the acute angle, for the angle theta equals, the reference angle theta prime equals 60. So 60 degree. We know the x and y's value. And for theta prime equals 45 degree. And this is the value of x and y's. Theta prime equals 30 degree. So the x, y's value provided for us in this picture. Okay, using the reference angle to evaluate functions, the sine 4 pi over 3. So first, I'd like to draw the picture, to draw the terminal side. Where is it? It is. This is a pi, this is pi over 2, this is 3 pi over 2. 4 pi over 3 is more than pi, so it's about here. What is the reference angle? Use 4 pi over 3, subtract pi. That's pi over 3. So I got pi over 3. This is the reference angle. So sine 4 pi, this is the theta prime. I must have pi over 3. Pi over 3 is square root of 3 over 2. And then we need to decide what is the value of this. Since we know it must have the same value of 3 pi over 2, but the sign before this value is maybe they are different. So it's in the third quadrant. The sign here is negative. So we must put a negative sign here. Right now we use the reference angle to evaluate the sine 4 pi over 3. Let's move on to see next one, tangent negative 225 degrees. So when I see this one, I'd like to convert it to the positive angle. So I can use coterminal angle. That means I use negative 225 plus 360. What is that? So 360 subtract 225. 5 3, 1, 1, 3, 5. Okay, so it should be here. 1, 3, 5 from here to here is 1, 3, 5. So the reference angle is 180 degrees. Subtract 1, 3, 5. That's 45. The reference angle is 45 degrees. Tangent 45 equals 1. And tangent negative 2 to 5 equals 1. And decide what's the sign of this one. Because it's in the second quadrant, only the sign is positive. Tangent is negative. So I put negative sign here. Next one, secant 11 pi over 6. First, I know that secant equals 1 over cosine 11 pi over 6 because I think a cosine is easier for me to calculate because I memorized the trig functions. Always just use the 3 basic trig function: sine, cosine, and tangent. So tangent is friendly for me. So right now we decide the reference angle because we know that this is pi, this is pi over 2, 3 pi over 2. 11 pi over 6 is here because this is 0. This 2 pi. 2 pi is also equals 12 pi over 6. So the reference angle equals 2 pi in the fourth quadrant equals 2 pi. Subtract 11 pi over 6. That's pi over 6. And the cosine pi over 6, that equals square root of 3 over 2. And decide is positive or negative. We still have A, S, T, C. The cosine here is positive. So SEC, secant 11 pi over 6 equals 1 over cosine 11 pi over 6 equals cosine pi over 6. The symbol here must be positive because the sign here in the fourth quadrant is positive. That equals 1 over cosine pi over 6 equals 2 over square root of 3, because just flip this and rationalize that. Multiply square root of 3 both sides. 2 times square root of 3, square root of 3. Oh, sorry. Square root of 3 times square root of 3 equals 2 times square root of 3 over 3. This is the final answer, and that's the positive. Next one, secant 9 pi over 2. For this one, I'd like to convert it to the cosine. Cosine 9 pi over 2. Let's see. Oh, it's still the second example. Okay, right now I need to find the reference angle. So draw the XY plane and 9 pi over 2. That's a very big number. So I'd like to make it smaller to find the coterminal angle first. So if 9 pi over 2 subtract n times some times 2 pi to make it be a smaller angle, I can easily to find in the XY plane. So 2 pi can be written like 4 pi over 2. 4 pi over 2, make them have the same denominator. So if n is 2, so 9 pi subtract n is 2 is 8 pi. 2 times 4 is 8 over 2. That's pi over 2. Oh, I see. My angle is here. So we find the angle is here. The reference angle should be 80 degree. So, but I also learned that I can pick any point on this part. I can pick any point. I try to pick the point P is 0 and positive 1. Just pick a point here. 0 positive 1. So the R equals 1 because it equals square root of x squared plus y squared. And this is my x, this is my y. So I'm looking for cosine. Cosine pi over 2. So cosine theta equals x over r. That's 0. So the cosine theta is 0. And the secant theta equals 1 over cosine theta. That's 1 over 0. It's undefined. So this one, first I use the coterminal angle to find what is its coterminal angle. And then I didn't use the reference angle. I just assign the point P equals XY, and then just assign a number, a point for this point. That means I have my X and Y's value and R's value. And then plug it in the cosine function equals Y over R. That's 0. And then do the reciprocal, flip it, we got 1 over 0. We find this is undefined. Okay, I have too many examples in my video, but in the face-to-face lecture, we won't have enough time to go over all of these examples. So if you feel you understand this and the example too much or the video is too long, you can skip this. Let's see next example. The sine negative 510 degree. This one. First, I'd like to know where is this angle on my graph, but it is a big negative number. So use the coterminal knowledge. We can coterminal angle knowledge. I can use negative 510 degrees plus 360. If it's very small, I will use it. If it's still too big, I can use 360 times 2. I think I'd better to use 360 times 2. That means negative 510 degree plus 720 degrees. That is 210. So 210. This is 90 degree. This is 180 degree. This 270 degree. So 210 is between this and this. Is in the third quadrant. So if in the third quadrant, 21 theta equals 21 0 degrees, subtract 180 degrees. That's 30 degrees. So this is the reference angle, 30 degrees. So sine 30 equals 1/2. And also we need to know in the third quadrant, sine must be negative. So sine negative 510 equals negative 1/2 because this is in the third quadrant. Okay, let's move on to see next part. This example, sine theta equals negative 4 over 7. Cosine theta is greater than 0. So I'd like to draw pictures because I know A, S, T, C. Sine is negative, so sine is here or here. And cosine is positive, so the sine must be in the, this theta must be in the fourth quadrant, for example, is here. So in here, the x is positive. The y value is negative because x here, this side, x is positive. This side, y is negative. Since we know sine theta equals -4/7, and also we know sine theta equals y over r, we can assign that y is -4, y is negative, r is 7 in the bottom part. Then let's find the x value, because we know that r equals square root of x. Oh, it's not very good, but I know that x squared plus y squared equal r squared. So plug in x, y, and r's value. X, we don't know, plus y is -4 squared equals 7 squared. So we can find x equal positive or negative square root of 33. And we know x must be positive, so x is square root of 33. Why sometimes it's very, the stroke is very thick. So we have the x, y, and r's value. We will find all of the 6 functions, and they only ask us cosine and tangent theta. So cosine theta equals x over r, which is square root of 33 over r is 7. And tangent theta equals y over x, that is, y is -4. X is square root of 33. Rationalize that, -4 square root of 3 over 33. Okay, let's move on. We have talked about this in previous lectures. So memorize these identities. These 9 identities are very important. Using the identities to solve the problem. The first one, cosine theta equals -3/5 for theta in the second quadrant is here. So we know that the identity is sine theta squared plus cosine theta squared equals 1. And we know the cosine theta, and so we can solve the sine theta. Sine square root of theta equals 1 subtract the cosine theta squared equals 1 minus -3/5 squared. That's 1 subtract 9/25. That is 25. That's 14. Is that 14? 25 minus 9. 16, sorry, 16. And sine theta equals the square root of this, right? Positive or negative, 16/25. So which symbol I should choose? Because it's here in the second quadrant, the sign is positive. So sine theta equals 4/5. This is a positive. So tangent theta equals, use the identities. Sine theta divided by cosine theta, that equals 4/5 over -3/5. That's -4/3. And the other 3 trig functions is very easy to find because cosecant theta equals 1 over sine theta, and plug in the sine theta there, we have 5/4. And secant theta equals 1 over cosine theta, and tangent theta equals 1 over, cotangent theta equals cotangent theta equals 1 over tangent theta. So by this way, you can find the angle. This is another way. Another way to find because we can also use the reference angle to find. Since from the image we know the angle is in the second quadrant. So by the we can assign that cosine theta equal -3 over 5. In the second quadrant, the x is negative, y is positive. So cosine equals x over r. R is always positive, so x is negative. So assign x equals -3, r equals 5. So we can easily to find y, because y plus x squared equals r squared. So y equals square root of positive or negative square root of r squared. Subtract x squared equals positive over negative. I think it's 4, because you plugged in the answer in it. And y here is positive. We know y is positive, so y is 4. So I have x equals -3, y equals 4, r equals 5. And sine theta equals y divided by r, cosine theta equals x divided by r, and tangent theta equals y over x. So plug in all the x, y, and r in it, you're going to find the six trig functions value. So the same question, we can use 2 ways to solve. Oh, last part, use the distance formula. The distance formula, if I have 2 points, maybe one is here, x and y, and another point here is a and b. The distance between these 2 points, I use the formula, which is x minus a squared plus y minus b squared to any point. So x and y and a and b. So x here, y is here, subtract a, y subtract b. You can also use, if you like, you can also use a minus y, a minus x squared plus b minus y squared. It doesn't matter which one goes first. So you can use these kind of formulas to find the distance between 2 points. In the example, find the distance between these 2 points. So the d equals 2 minus -1. Oh, yes, squared. 2 minus -1 squared plus 5 minus 11 squared, and we have this. Okay, I think this is a very long video. If you have any question, please let me know. You can also skip some part of the examples, because some examples are very similar. If you can also visit the tutoring session if you have any question. Okay, have a good day.